The topic that we are going to see today is user-defined functions provided by C language. So that's the topic for today. First, we can try to understand why we need user-defined functions. Let me try to motivate by giving you an example program, and I'm going to show you the screen in your computer that you're going to see when a program is executed. Suppose this is the screen that you are seeing when you execute a program. So what is it? It says these are the functionalities. So you can read a number, and if you have a number, you can find factorial of that number. You can convert that into binary. You can find the digit sum of that number. You can check that number is prime or not. You can repeatedly do this, or you can exit from the execution. So these are the options that you can give, and now the current number is undefined. Okay. If you want, you can read a number using option 1. Then the program is asking you as a user to provide your option, one of the 6 options you can give. Now suppose I am giving option number 1, then what is it doing? Okay, the program is asking to give a decimal number. Suppose you are giving 13 as a number. Then now the current number is 13. Again, you can give your option. Suppose you give 3 as the option. So you want to find the digit sum. Then the output is the sum of the digits of this number is 4. That's correct. Now you can, if you want, you can say I want to find whether the okay, I want to convert it into binary. Then this is the output. Okay, it's the binary equivalent. Then I say I want to check whether this number is prime or not. 13 is a prime number, so I am getting that output. Finally, I am going to exit the execution. Then the program finishes. Suppose this is what you want to implement. This looks like a nice program because repeatedly you can perform any one of the various operations allowed on a number. So how will you do this? We can see when you can use user-defined functions, your main function will look something like this. So here I mean in the printf statement, you print the table that you have shown, that I have shown. Okay, you print that table, you can decide how to print. Okay, you may not have to worry about the lines and all, you just display that information. Then enter your option. This is what I printed. Then you take that option into a variable. Then this is how I can manage. Depending on the option, if it is case 1, then call a function to read a number. If it is case 2, call a function to find the factorial. Likewise it goes. So it's just a switch statement within a loop, and you have to continue executing the loop until the user enters the option to exit. So this is what you can do. Now you can have a function to read a number, a function to find the factorial. I'm assuming that printf will happen within the function itself. Then a function to find the digit sum, another function to find the binary equivalent, and finally we can have a primality checking function. And see how easily I can understand what the code is doing if I have such a code. So there is a standalone separate module or function for each of the functionality. Thus, if you are going for user-defined function, you can view a C program as a set of communicating functions. This should be program is a set of communicating functions. Okay, this is a motivating example. Now we can look at a concrete example. Here I have a program. What does it do? It is to find the largest of three numbers. Then how is it finding it? It finds the largest by using a user-defined function max. See, here I am calling a user-defined function max, which is to find the largest of two numbers passed to it as arguments. So in the program, I am reading three decimal numbers A, B and C. Then using the max, I am finding the maximum of A and B and assigning it in this variable. Then this is the local maximum, and that local maximum is compared with the last number C, and thus I am finding the required largest. Now let us see how it works. So I assume that I am defining a user-defined function max to find the maximum of two decimal integers. Now suppose you execute this program. So this shows, okay, I am just calling that main function. When a function like main or f is invoked or called during execution, its instance is created in memory and its variables are getting memory allocated. Instance means a copy of the executable function is loaded into the memory, and memory is allocated for all the variables in it. Here decimal variables A, B and C, and a decimal variable D max, and another one D largest. These are the 5 variables. All these variables are getting memory allocated. Here the assumption is that 2 bytes of memory is required for every decimal integer. Okay, now the moment you execute the program, the first function to execute is main. So the first function instance is created in memory, and then it comes to the first statement, which is a printf. If you execute, this message is getting printed. Then you proceed to the next, which is a scanf statement, because there are 3 input values you are trying to read. It will wait for the user to supply 3 decimal integers. Suppose the user is giving 10, 30 and 20. It can proceed. Now all these are undefined. If you finish that scanf, the corresponding values are taken into A, B and C, decimal variables. Now it progresses to the next statement. See, it's interesting here. You're trying to assign the maximum of A and B, the decimal variables A and B, into this variable. But that you are doing by calling a user-defined function. So this is a function call. So what happens now is the control gem. See, a function call is represented using the purple color. Okay, and the internal execution is using blue color. So function call happens. The program control comes to the called function, which is max. And now note that previously the max instance was not there in the memory. So now when I call, an instance of max is created in memory, its variables are getting memory allocated. And now you can see that the variables are dx and dy and dmax. Okay, and the arguments are passed. Now you can see that from here the value of dA, which is 10, and the value of dB, which is 30, is passed, and which are now copied into the corresponding arguments here. Dx is getting 10 and dy is getting 30. Okay, that's how it happens. Now it progresses down in the function. It comes to this condition checking. Dx of this instance is 10, which is not greater than 30. So the condition check fails, and thus the control comes to the else part. And note that here dmax is there in both main and max. Both are 2 functions. So note that dmax is there for the main, and dmax, the same variable, is also used in max. That is possible. Separate functions can have variables of the same name, but each one will be having a separate memory location allocated. So the Dmax of max is now getting the value of dy, which is 30. Yeah. And now it comes to this statement. What is it? It's a control statement. Return is a control statement to pass control back to the calling function, which is main, from the called function, now in this case max. And it also returns not only the control but the value of Dmax, which is now 30. Now it is going to return to this point. It is returning, and not that previously it was a function call, and this function call will be replaced with the value returned, which is 30. Okay, that's what's happening. Now that function call finished. When a function instance completes its execution, the instance is also getting deleted. That instance of max is now not existing. Okay, so function call finished. Now it progresses by assigning 30 to the Dmax variable of main. And then it proceeds down to the next statement, which is again a function call. It happens to the same function again. Now the variables are Dmax from here, which is now 30, is copied to dx. The first argument is getting Dmax, which is 30. Second argument is dc, which is 20. So 30 and 20 are getting in. You're getting into dx and dy of max, and you're proceeding down. Now dx, which is 30, is greater than dy, which is 20. So the condition evaluates to true, and control comes to the if statement, and in that the Dmax variable of the max function is getting the value which is in dx now. What is it? It's 30. So 30 is copied into Dmax, and now it goes to a return statement. You know what is going to happen. The control is coming back to this statement, and previously it was this call, now replaced with 30. And thus that function instance is also finished. It goes to the last statement, which is the print of, it just prints the largest of three numbers that it found. And then because it finishes the last statement of the main function, that also is finished, and that instance is getting deleted. Okay, that is how a C program with multiple functions executes, regardless of whether these functions are user defined or library functions. Okay, now we can try to recollect what we have seen from the example. User defined functions are self-contained units in a program with a standalone purpose, like finding the maximum of two numbers. When a function like max is called or invoked during execution, the program control gets transferred to the call function, say max. The call function is executed until the program control reaches a return statement, or it comes to the last statement of the called function, and then the control is passed back to the calling function. In the previous example, main was the calling function and max was the called function. Variable declared in a function f are getting memory allocated each time when f is invoked for execution. That means whenever you execute f, an instance of f is created for execution, and the memory becomes not accessible when the instance completes its execution. And these are what we have observed from that example function execution. Now we can look at another concrete example to see why we need user-defined functions. And here is a program which is to find the number of R permutations of n objects. We know that it is nothing but n factorial divided by n minus r factorial. So we need to find factorial twice for solving this problem. Now here what I did is I assumed that there is a user defined function to find factorial. So I can just make a call to that to find the factorial of the decimal number n, and the same function can again be called to find the factorial of dn minus dr. This is exactly what I need. So I assume the existence of such a function which I can define. And now you can see that user-defined function allows you to divide the program into modules or functions like this. And it makes the logic clear. Now if you look at this, you can see that it's nothing but, okay, factorial of n divided by factorial of n minus r. This is exactly what you need. But assume you are not having this function and you have used the for loop twice in this code, then it may not be that readable. And also, it enables to avoid redundant coding. And suppose this function is not there, then the code to find the factorial must be repeated twice for this particular requirement. These are some example applications that you can see. Now, let us try to understand the syntax for function definition by using an example. Here is a function called foo. Try to understand the components in it. This is the data type of the function, which represents the type of the value to be returned from the function. Y is not required from the function. So this function is going to return a floating point value, and that's what it's saying. What kind of a value it returns, followed by the name of the function, in this case foo. Then a finite set of arguments separated by comma within parentheses. And each argument is having a data type associated with it. Here it's int for both, and the data type followed by the identifier representing the argument. That's it. Then it follows the function body. Within curly braces is a compound statement defining the required functionality or code to implement the required functionality. Now, this is what we have seen. This is the syntax. Here it starts with the data type, which is the type of the data to be returned, followed by the function name, a finite number of n arguments, and each argument is having a data type and the name of the argument, and the arguments are separated by a comma, and followed by the function body, which is a compound statement implementing the required functionality. So that is the syntax. Now we can look at the, this is the syntax for defining a function. Now we can look at the syntax and semantics for function invocation or function call. It's like this: function name followed by arguments within parentheses. A function can be invoked or called by using the function name. When a function invocation is processed during execution, a function instance is created and the program control gets transferred to the newly created instance. This is what we see. And the actual argument, when you pass the values in the function call, they are called actual arguments. Okay? And when you define the function, you are giving data type and argument name, where it is called the formal argument. Here, these are actual arguments used in a function call. Argument I can be an expression which will be evaluated to a value of type compatible with the data type of the ith formal argument. Suppose the second formal argument is number, here you have to pass a number. That's what I mean. Each invocation of the function causes the transfer of the value of the ith actual argument to the variable representing the ith formal argument in the instance of the function being created. That means if you are passing 10 here, the function instance will get 10 assigned to the second argument. That's what I mean. So function declaration, when you want to declare a function, here you can see that fact is a function which is declared over here. And what's it? This is the function, and you can see that a function declaration is required when a function, say bar, here in this case fact, is called from another function foo, in this case main, and the function bar is defined after the definition of foo in the program text. Suppose you have two functions, bar and foo is calling bar, and but you don't need declaration if bar is defined before foo in the text. Otherwise, you need it. I hope you're getting. Otherwise, please read it offline and think about it. And here, if you want, you don't want to. If you want, you can avoid specifying the variable name. You can just say int, and that is function declaration. So we have seen that user-defined functions enables a programmer to create her or his own library. Maybe you can add a function to find the factorial, for primality checking, to find the factors, etc. You can add into the library. And a program in C can be viewed as a set of communicating functions. And the communication among the functions are implemented using function calls and returns, function invocations and returns. During function invocation, you can pass a number of arguments into the function call, and from the call function, you can only return a single value using the return statement. And the execution of every C program starts with the main function. So in every C program, there must be a unique main function. You try defining a program without this function. You can see that the compiler will not flag any error. But when you try to run, it will give you an error because the execution should start in the unique main function. You try various possibilities in your lab and try to understand how it happens. And on invoking a function bar from another function foo, what happens? The execution of foo is temporarily interrupted. Foo is calling bar, then execution of foo is temporarily interrupted, and the program control gets transferred from foo to bar, and it returns to foo only when the called function bar finishes its execution. That's either it comes to the last statement or it comes to a return statement. And once control gets back to foo after executing the function bar, the execution of foo is resumed from the point where bar was invoked. We have seen in that example. Twice we have called the max function. So once it returns, it goes to exactly that point and resumes that calling function from there. And with this, we are finishing this lecture, and I'm giving you a homework exercise for you to write a menu-driven program with these functionalities. So you provide a single user-defined function for each of these functionalities. So today, we have seen user-defined functions. We saw why we need user-defined functions, how we can define them, how we can call or invoke them. And we also have looked at the advantages of using user-defined functions in C. Thank you.